Hi, this is Thea Jackson doing my post lesson for Foundations of Math. My instructor told me that it would be fine if I did it in this format since I do not teach elementary school nor do I teach math at the moment. So here we go. Here is my lesson that I did, which was 43 minus 27. The first method I'm going to show after taking the class, I realized the importance of demonstrating to kids what constructing and deconstructing means. So previous to doing this lesson, things that I would expect the kids to know and things that I would have taught already is what ways could we actually demonstrate the numbers 43 and 27. And to make that easier, I would have start with just the number 40. So what are the different ways we could demonstrate 40? We could have 4 sets of 10, or we could have 3 sets of 10 and another set of 10 ones. Once they got comfortable with that, then we would move into the problem at hand, which today is 43 minus 27. By having them do it with manipulatives, it shows that they can both construct and deconstruct a number with their hands. So I would have them know how to do that before moving on to the next one. So after they were comfortable with doing that, this is where I would pick up with the lesson. The first thing I would show them is the keeping the distance method. So that, of course, is using a number line. So the problem is 43 minus 27. So we have our number line. We have 43, and so I would ask the kiddos to find 27, right? And what we're really looking for is what is the distance between this number and this number. So I think when kids are trying to get a strong sense of number sense for their first 10 and then facts within 20 and then facts within 50, sometimes the larger the number, the kids can get confused. So if you think about it realistically, it's easier for our brain to compute something based on a base 10 number. So if we went up 3 to 30 and then went from 43 to 46, we could show the kids that that is easier to do in our head. It's quicker to do in our head because you're working with a nice base 10 benchmark number, and that the difference between these two is the same. There's 16 digits in between 43 minus 27, and there's still 16 digits between 46 and 30. So this way they could see, not only do the math, but they could also see the difference between, oh, okay, so there's multiple ways I can represent even the fact that there is a difference. This is a difference of 16, and so is this. And then I would ask them to go on and find me other ways that represent a difference of 16. The second method I would show is the number between. I particularly like this one because it shows the students a very nice relationship between addition and subtraction, and it also shows them how to deconstruct a number. So before we did it this way, I would ask them to do it this way. Okay, so here's one of the things we have. Here's 43 with 4 10s and 3 1s. We would deconstruct that into 3 sets of 10 and 13 1s. And then before we did anything on paper, I would have them do several problems, not just this one, where they actually physically take away. So I'm going to take away my 25, 7. And then what do I have left? And the kids can easily see that that's 16. And then I would turn that into an addition problem. So then what is 16 plus 27? And they can see that relationship there, that's now 43. So I think that shows it very nicely. The second method I would show them is the number between. There's 2 ways to do this. So the actual problem is 43 minus 27. So what I would do is, since we just got off a number line where the kids were taking 27 and rounding it to 30, and say, okay, well, what are 2 base 10 numbers that would make this computation in our head quick and efficient? And I'm pretty sure the kids would go to 40. And to get there, there's a difference of 3. Now this always has to be addition because this side is always going to be subtraction. If they want to take 27 and round it to 30, there's a difference of, again, 3. So once I do that, I'm going to take my 4 10s, or 40, minus 30, which is going to leave me with 10, and then my 3 1s plus 3 1s is 6, for a total of 16, which happens to be the correct answer. The other way you can do this is to find the same number that is in between these two numbers. So we could do 43 minus 27. It would make the most sense to choose 30 because it's an easy benchmark number, base 10 number. So in order to get to that 30, there's a difference of 13 digits or 13 ones in between this and this. If I'm going to make this 30, there's a difference of 3 in order to get myself up to 30. So when I compute this as well, 3 tens minus 3 tens or 31s minus 31s is 0. And then I'm going to add my 13 plus 3 is 16. So either method will work and get you the correct answer. The third method I would show, and this would be helpful for kids who are just learning how to construct and deconstruct numbers, is expanded form. So if we were doing 43 minus 27, we would have already at the beginning of class done hands-on experimental stuff with this versus this. 43, 43, we would have represented it in other ways, so kids would have an understanding of the different ways that we could make these numbers. They also would have practiced, and this is where I would actually have them use these first before they do anything on paper here as well. We would go back, we would review whether it's the same lesson or a different lesson. Okay, so if I have 10, 20, 30, 43, and I'm taking away 27, again, they can see that relationship there. So I would start with that and just kind of remind them that we're doing the same thing just in multiple ways. So when we're breaking this number down, we would actually want it to look like this. So we would have 10 plus 10 plus 10. So there's my 30, and then my 13 ones. And if I'm taking away 27, we're also going to represent that in expanded form. 10 plus 10 plus 7. And we're going to subtract that. So these cross each other out. So before I even do anything, we're going to get rid of anything that's alike. And then 10 minus 0 is still going to be 10. And 13 minus 7 is going to be 6. So my answer once again is 16. Another way you can do this for a kid who may be struggling with that is actually you could write it out and use the word tens versus ones if they're having a difficult time figuring out placement. The last method I would show, and this one's a little more complicated, so I may give this to a student who shows that they're beyond all of this and that they're ready for something a little trickier, is subtracting with negatives. So in this method, if we're doing 43 minus 27, the kids would have to understand that here we have some tens and here we have some ones. We're not going to construct, we're not going to deconstruct. We're simply going to use, out of all the methods, this is the most abstract and the most efficient. And some kids in our classrooms would be ready for this. So 4 tens minus 2 tens is 2 tens. And then 3 ones minus 7 ones is negative 4 ones. And at the beginning, I would actually have them write this out, okay? So now the question is, well, what do we do? Because we can't combine these because the answer is not 24. So we're actually saying if we have 2 tens, which is 20, plus minus 4 ones, what does that equal? And it comes out to 16 ones. Again, kids would have to really demonstrate that they understand both construction and deconstruction of numbers. So those are the 4 ways after taking this class that I would show this, as opposed to the original method of carrying, which is something that I don't think they do in schools anymore and probably does not need to be shown. Children have to first show that they understand what the numbers are used for, understand the relationship between addition and subtraction, and I don't know that borrowing does that. It makes it sound like they're 2 separate numbers as opposed to kids really showing that they understand what 43 is and what 27 is. So it makes more sense that the research is backing up that children do better understanding this than they did back in the older times where we just borrowed and just did it just to do it. It was based on computation, not on understanding. So that's my lesson. Thank you.